Good morning all, this is Swapna. Welcome to machine learning video. Today we are going to learn about comparing the performance of two different learning algorithms. So, comparing the performance of two learning algorithms, here we are considering first learning algorithm is LA and second learning algorithm is LB. Rather than two specific hypotheses, here to determine one method is rather than using the two specific hypotheses, two methods we are specifying. First method is, as an average, is to consider the relative performance of two algorithms averaged over all the training sets of size and over the distribution. And second method is expected value of difference in their errors. In first method, rather than considering the two hypotheses, here we are considering only the one hypothesis. In that, to determine that also, to measure the performance or to compare the performance, there are two methods. First method is, we are considering as an average value. As an average value of that one, whatever the relative performance is there of the two algorithms on all the training sets over the distribution. And second method is finding the expected value of difference in their errors. So, this one is the first one. This is the formula to find out that here L of S within this formula, E is S is subset of distribution. S is the sample subset of distribution. D, true error D we are specifying. LA of S. LA is our first algorithm and sample whatever we are taking, unique sample only for these two algorithms. LA and LB is the two algorithms. Error D if you are specifying means we are considering the true error. We are finding the difference between these two errors. Finding the error of difference between these two errors, which are on the particular sample, which are belonging to the particular distribution. So here L of S denotes the hypothesis output by learning method of L, which when give the sample of S, that's what here we have specified depending upon the formula. So whatever the sample is there, that is divided into the training set of S0 and test set is T0. Whatever the sample is, the complete distribution of sample is there, within that limited sample we are considering D0. Within that also S0 sample is related, D0 sample. On the complete distribution we are considering the one limited sample, that is D0, and that is divided into the training set and test set. Training set is represented with the S0 and test set is represented with the T0. And algorithms here is same thing, LA and LB. What is the quantity? So that's what is the difference between these two on that particular hypothesis. With the training set. So the key differences between this estimator and the quantity. So we are using the error T0 to approximate the error D. Error D is the true error, and whatever the error we are getting with the testing set. So measuring the difference in errors for one training set S0, rather than taking the expected values of this difference over all S that might be drawn from the distribution. Here is one thing, we are finding the difference between errors of one training set sample S0. So we are giving as the step-by-step algorithm procedure, D0 into the disjoint training sets and test sets. So partition the available data D0 into the K disjoint subsets. It is divided into the different subsets of testing sets and training sets. That number, how many disjoint subset we are divided, that is represented with the K. And here we are considering only the one condition, thumb rule condition is at least everything it will contain the size of at least 30. So we are iterating from I to K, because K disjoint subsets we are divided this available data. So that we are continuing K1 to N, 1 to K. So from 1 to K, every subset we are iterating. So use Ti for the test set and remaining data, whatever the data is there, remaining is that we are considering as a training set. So for SI is it came from the distribution T0. What is SI? From the distribution T0, whatever the testing set is removed, then what we are got remaining data, that is SA. And HA is the hypothesis which on that particular sample on particular algorithm LA. Second one is also same thing. If you find that error of this on this particular hypothesis, error on that particular hypothesis with this test data, so difference between these two is represented with the delta. So return the value of delta with the bar, where delta with the bar is summation of all these, for every particular value. What is the error difference is there, but the mean value of that one is represented with the delta bar. A procedure to estimate the difference in error between the two learning methods is approximating the confidence intervals for this estimate are given. So here another thing, whatever is given, estimating the difference between these two is considering the approximate intervals between the estimation of these two. So one way to improve on estimator is to repeatedly partition the data D0 into the disjoint training sets and test sets and find the mean of the test set errors with the different experiments. That is the one way to improve the estimator. What is estimator? Sample error we are considering as a estimator for the true error only. What is the sample error you are getting? That we can considering as a true error. That is only we learned that we are considering sample error we are considering as a estimator, that we learned in previous videos. So this procedure first partition the data into k disjoint subsets of equal size. Here we are dividing that complete distributed data into the k different type of subsets, but every subset is containing the equal size, that is at least equals to 30. If then trains and test the learning algorithms k times this, every time for every test we are training, we did the training and also we tested that one by using each of the k subset in turn the test set and using all the remaining data as a training set. In this way the learning algorithms are tested at k independent test sets with the k independent. So what mean difference we are finding, that is represented with the delta. So that is standard as a estimate of the difference between the two learning algorithms. So what we can say, delta mean estimate of the quantity is like this. So S represents the random sample of size and D0 is drawn uniformly from D0. Approximate the n percentile confidence interval. How we are considering the n percentile confidence interval? Mean plus or minus Tn k minus 1 of S of delta. So what are the notations we used, that we are going to know about the notations in this slide. Tn comma k minus 1 is a constant that plays a role of analogous to the Zn. So to find the confidence interval we used the constant Zn. It is Tn comma k minus 1 acting as just like the Z to find the confidence interval, where S delta bar, it is an estimate of the standard deviation of the distribution, and delta bar we said as a mean, and S delta bar is a standard deviation. So to find out that, this is the formula to find out the standard deviation of that particular one. So we can find by using this formula. So first specify the desired confidence level as it did for our earlier constant is Zn. Here we are using Tn comma k minus 1 as a what we can say constant. The second parameter, first one here we have specified, that is same thing. The second parameter is called the number of degrees of freedom and usually denoted by v. It is related to the number of independent random events that go into the producing the random variable particular n. So here we have to find the confidence interval. Here in this table, values of V is given with the confidence levels of percentile in the form of percentile. So previously we said Zn, here we are considering as Tn comma y k minus v. Here what we are considering v. And what is the two-sided confidence interval with the confidence probability percentile is 90%, 95%, 98% with the 99%. These are the v values. Here we are given with the predefined table. So this procedure described here for comparing the two learning algorithms involves the testing the two learned hypotheses on identical test sets. So here we are considering the one more procedure. two learning algorithms, two learning methods we are considering, and testing on the two learned hypothesis. Not only for the single hypothesis, we can go to the two learned hypothesis. Comparing the hypotheses that have been evaluated using the two independent test sets. Test sets where the hypotheses are evaluated over the identical samples are called the paired tests. So here what is the paired test means? Here it is taking the two different test sets which are related to the particular sample only, and the particular hypothesis at a time. That we can call as paired tests. Paired test typically procedure titled the confidence interval because the differences observed in errors in a paired test due to the differences between the hypotheses. In contrast, when the hypotheses are tested on the separated data samples, differences in the two sample errors might be partially attributed to differences in the make of two different samples. Here how we are getting the differences means from the observed errors with the paired test means whatever the hypothesis you are considering for that particular sample, and if you are taking the different samples, then also you may get the difference of value while you are observing the errors. So for this it is given step-by-step procedure and the formula. Consider the following estimation problem. Here we are going to estimate. So we are given the observed values of set of independently identically distributed random variables. Here random variables are represented with the y1 to yk. Here we are taking the k different sets. To find the estimate, the mean value is mu and probability of distribution we are considering over the y of I. The estimator what we are getting is here like this y bar we are representing, and summation of all these mean is represented as y bar. So the problem of estimating the distribution mean p based on the sample mean. Here is y bar, and we need to find out the distribution of this one. So that is represented with the smallest p. So these are the general steps while comparing the learning methods is assume that instead of having a fixed sample of data D0, we can request new training examples drawn according to the underlying instant distribution. From the distribution, instead of taking the same sample set, we can go for the another sample also. Modify the steps of on each iteration through the loop. It generates the new random training set and test sets. For every different sample, it may generate the different training sets and different test sets of k different subsets. So by drawing this underlying instant distribution, instead of drawing from underlying instant distribution, fixed sample D0. To find the confidence interval, this is the formula. And we can find the standard deviation by using this type of formula. In that also what already we know, these are the y bar how you to calculate, and this we can already tell you this is the constant, this is the standard deviation. So this is we can already told you Tn comma k minus 1 is a constant which are we used as a certain for earlier formulas to find out the confidence interval. So this is acting as a constant, and probability distribution known as T distribution, just as the constant Z characterizes the area under normal distribution. Here also we are considering normal distribution. Normal distribution shape is bell-shaped distribution only. So when this distribution is considering as a normal distribution means whenever k approaches to infinity, if you are taking the k number of subsets, maximum large number of subsets on the particular sample, different training sets and different tests, then it will act as a normal distribution only. Whatever the calculated, we are calculated the mean, variance and standard deviation that are becoming as a exactly of normal distribution. Mean, normal mean distribution variance and normal distribution standard deviation. So what are the maximum practical considerations while we are what we did till now comparing the learning algorithms? First what we took two learning algorithms with a particular sample we are applied the two learning algorithms on the same sample, and after that we find the difference between these two, and continuously we find this with this different hypothesis also. Like this we are compared the different learning algorithms, different hypotheses, and what are the practical considerations is. So, what is the practical consideration or practical problem is, whenever you are taking the new sample from the D0, every time you are taking the new sample, within that also you are dividing that one into the number of different training examples and different testing examples. Here, when you are finding the error of these training examples and test sets within these samples, and every time you are taking the new sample, there may be a chance of overlapping of training examples. Whatever the training examples randomly chosen for S1, that within that some training examples which may also come into the S2 also. So there is a chance of occurring that one also. Next one is k-fold method, in which D0 is partitioned into the k disjoint equal sized subset. K-fold approach is each example from the D0 is used exactly once in the test set and k minus 1 times in the training set. So whatever the example we are in this k-fold approach, that example may be exactly once. While you are taking the different type of test sets, just consider whatever the example you are considered as a test set. That example may be in the another sample, it may act as a training set. That is k minus times. There is a chance of occurring k minus times that test set. Whatever the training example present in this test set of S1 within the different subsets, it may acting as a training examples. There is a chance of occurring when we are going for the k-fold method for that particular distribution D0. What is the second popular approach is to randomly choose a test set of at least 30 examples from D0. Use the remaining examples for training. Then repeat this process as many times as desired. So this one we are repeating as many times as possible. This randomized method has the advantage that it can be repeated an independent number of times to shrink the confidence intervals of the desired width. We want to shrink that confidence interval, that for that purpose we are continuously repeating that one. And in contrast to this k-fold method, here we are considering one more method. Each example only once in the test set. Consider that example only when they come occur in the test set only once, and our desired to use that sample size at least 30. So, however, randomized method has the disadvantage that the test sets no longer qualify as being independently drawn with respect to the underlying instance distribution. In contrast to the test sets generated by the k-fold cross-validation independent, because each instance is included only once in the test set. Whenever you are choosing the randomly some examples as a test set and remaining is acting as a training example. At that time also, contrast to the k-fold method, we are considering whatever the examples once comes in the only one time it needs to come in the test set. Whenever you are choosing for the another test set, just be careful of there is no repetition of whatever the training, whatever the drawn example is already previously used as test set. That we are considering another method. So by this I am concluding this video. This is the last video which are related to this one, basic sampling data. So comparing the learning algorithms. Thank you. We'll meet in the next video.